Let's talk about my question. My question is to find the minimum of this function subject to these three constraints. And I have rewrite my function in this form. I find that here we got a -3. It's a negative constant. So we can find the maximum of x squared plus y squared in order to find the minimum of the initial function. So my question turns to this form. And my constraints need to be rewritten. It should be in this form: gx equals to the left hand side no greater than 0. And set up the Lagrangian function. The first order condition of x and y correspondingly, and it's the second order condition. Firstly, we write down the Hessian matrix here, so we can have it when we discuss of the second order conditions in each cases later, we can find out the Hessian matrix quickly if needed. Now it's the KKT conditions. We have 4 attentions, 4 points to need to be pay attention. The first one is the stationary point. We need to find out the local stationary point, so we set up the first order conditions equations equals to 0. And now it's the second is the primal feasibility. We need to satisfy the 3 constraints. And the third is the dual feasibility, that all lambda should grade no less than 0. And the complementary slackness. We have the 3 elements inside the Lagrangian function equals to 0. Here is the 8 cases I have discussed. It depends on the different arrangement of the binding constraints. When solve the cases, we need, in the first step, is to substitute all the knowing elements into equations we needed that to solve out x, y, and also lambda. And the second step is use the x, y to check whether it is satisfy the constraints and all the KKT conditions. And the third part is discuss the second order conditions. In these cases, we need to discuss the Hessian matrix. It is positive defined and local minimum. So we got x, y, and lambda. And this is the second cases. And this case 3. In this case, we got 2 group of x and y. We should discuss it separately. And we find one is unsatisfied, the KKT conditions, and the other one is here. And this is case 4. Both x and y, both group of x and y are not satisfied. And this is case 5. And the first one is no solution. And for the x equals to -3 and y equals to -2, we go. And case 6. And this is case 7. And this is case 8. In conclusion, we got this table, and we find that the case 5 we have discussed have the maximum fx f function. Then we substitute into u function, find the minimum. this is the final answer with the graphs.